Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my programmingforkids.info website and at my programmingforkids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 25 creates more clones with 2 challenges, including a colorful psychedelic worm, and ends by showing how to hide a variable's monitor on the stage. I'll get started. On this challenge, I'll make a simple program that creates clones to make an interesting visual effect of a colorful crawling worm, but the clones won't move. I'm not going to use the cat. I'll delete the cat. I'll get a new sprite, things, scroll down. I'll use the flower shape. First I'll make an interesting effect with one sprite, then I'll make clones in different locations to make the image appear as if it's moving. I always want to start in the middle. I'll use go-to. I want to go to 0, 0. Events, when a green flag is clicked. First I want my sprite to shrink and disappear, then I'll worry about clones. The sprite will start at 100% size and shrink until it's less than 10%. I'll go to looks. I'll get set size, start at 100%. I want to shrink it until it's less than 10%. Control, repeat until, operators, less than 10. I'll get the size variable, looks, scroll down, size. I want to keep changing the size, change size, change it by a -10, that'll shrink it some. This will go too quickly. I'll go to control, put a wait for a second, it'll be good enough for now. Give it a try, I'll stop and run. Sprite is shrinking, getting smaller, smaller, still highlighted. The program is finished. I'll stop the program. Might be a little more interesting to have the color effect change. I'll go back to looks. I'll get change color effect. Give this a try, make sure it's stopped. Start. Color's changing as it's shrinking. Good. Couple more and then that'll be finished. And stopped. I'll make sure it's stopped. What if I had another flower-shaped sprite on the right of this sprite doing the same thing but starting 1 second later? It would be like the sprite on the left did a second earlier. It would be one size larger and one color earlier in its color progression through the rainbow. I'm not going to copy this flower sprite. I'll make a clone now instead. First I'll change this to work with one clone. I'll go to Control, create a clone. Where should I create? When the green flag is clicked, I want to create the clone. Then when I start as a clone, it'll run the repeat. I'll give this a try. Make sure it's stopped. Run. Nothing seems to be happening. Green flag is still lit and stopped. The program finished, didn't see anything. Try again. Move the sprite out of the way. Here's the clone that's shrinking. This is the original flower-shaped sprite. I'll hide the creating sprite. I'll go to Looks, get Hide, put that up at the very beginning. It'll immediately be hiding when the green flag is clicked. Will this work now? Be careful. I'll give it a try. Start. Now I don't see anything at all. Green flag is still lit. The program's running. Nothing is visible. Why is that? That's because clones inherit attributes of the creating sprite, including getting the same XY position on the stage and the same visibility attributes, like hidden in this case. The clone's being created by a hidden sprite, it'll need to show itself to be seen. I'll give this a try. Make sure it's stopped. Run. Now I see the sprite shrinking and changing colors. Good. It's finished, but it's still visible. I wanted it to disappear when it was finished. Easy enough to do. I'll go to Control, delete this clone. Now, after the sprite is finished shrinking and shrinking till its size is less than 10, it'll remove itself from the stage. Rerun it. Shrinking, still going, just about there. Now when it gets to the smallest value, it should disappear. The program is stopped. Great. Now I can create more clones. I'll move this down, make some room. I'll use a forever loop. Forever creating clones. I'm going to want the clones to be in different positions on the screen. I'll tell it to move. Go to Motion. I'll move 10 steps. Change it to 20 to make a little more room. I don't want to create the clones too quickly. I'll add a weight. Give this a try. Run. Now the new clones are made to the right. Each clone here is changing size as it's going on. I'll stop it and go to my diagram. When I stopped the program, it looked like this. Clone number 1 is the smallest clone and furthest from the original color. Each clone, 2, 3, 4, up through 10, is to the right. Remember, the clones don't move. Each clone is created in a different location, and each clone shrinks and changes colors before it disappears. This makes it look like the worm is moving to the right. Now the worm hits the edge. I want to steer the worm around and have it follow the mouse pointer. How can I do that? I want to point towards the mouse pointer. Go to Motion. Point towards, before the move, point towards mouse pointer. Move this down a little bit. Give this a try. Stop. Run. Now it's moving towards the mouse, slowly, but moving. Good. I'll stop it. Now that it's working, I can speed it up. If it waits a little bit less, it'll be created sooner. Change them to half a second, both of them. 0.5. Give this a try. Faster. Stop it and try again. What happens if I make the weights a quarter of a second? 0.25. I'll try that. Ready to run. Try it. Following the mouse nicely. Good. A little faster. I'll stop it. If I make it a tenth of a second, change it to 0.1. Try it now. Well, it's certainly faster. Moving very nicely. Good. I'll stop it. How can I make the worm longer? If the clones are displayed for a longer time, then the worm will be longer. If I make the size change by a smaller number, it'll take longer to become less than 10, so the worm will be visible longer. I'll change the size by -5. I'll try this. The worm is longer, about twice as long. Good. I'll stop it. How can I make the color changes smoother? I can decrease the change color effect number. I'll change it from 25 to 10. Try it. Now the color is not changing quite so abruptly. Good. Try one more change. Make the change even smaller. Instead of 10, try 7. Run. Nice smooth color changes there. Very nice. I'll stop it. I'm finished with the challenge. As always, I encourage you to play with the program and get comfortable with clones. Try changing the program. Change the wait times, the size change, and the color effect changes. Try using different costumes. Or try making the worm move differently. But above all, have fun with the program. In this challenge, I'll create a sprite with a couple clone sprites that interactively fly away from the creating sprite. It's a simple start that could be expanded into something like fireworks. I'll delete the cat, delete, new sprite, holiday, star 1. I want the sprite in the center. Go to 0, 0. When the green flag is clicked on, good. I'll center it now. I'll use a couple lists to let each sprite know how to change its XY position each time it moves. I'll want each sprite, the creating sprite, and the clones to have a unique index. The creating sprite will use the list index 1, and the unique ID for each clone will be 2 or more. I'll create the lists delta X and delta Y. Delta means change in X and change in Y. I'll go to Data, make a list, delta X for all sprites. Okay. I'll move this over, initialize it, delete, all, add, duplicate, duplicate. For delta X, I want sprite 1, which will be the creating sprite, to stay in the center. Its X position won't change, it'll be 0. The first clone sprite will change X in a +3, and Y, it'll move to the upper right. The second clone, index number 3, will change its X position by -3, will move down to the left. I'll create delta Y now, make a list, delta Y, global, bring it over. I'll copy this code, change delta X to delta Y. Now both lists are initialized. I'll make a procedure block to initialize the lists. More blocks. Make a block. I'll call it initialize delta lists. Okay. Do that at initialization. Initialize the list. Put this up over here. Try this now. Stop. Run. Lists are initialized. Shrink the monitors, move them down a little bit. That's good. Each sprite will have a unique index value into these lists. The creating sprite will have index 1, the first clone will have index 2, the second clone will have index 3. I'll stop the program and create the clone sprites now. Control, create clone of myself. Each sprite needs to have its own index into the lists. Data, make a variable, call it my index for this sprite only. Okay. Now each sprite has its own index. I'll set the creating sprite's my index to 1. The creating sprite needs to tell each clone its unique index value. make a variable, call it new clone index. Okay. Bring the monitor down. It's global so all the sprites can see it. I want to set the variable. New clone index. First clone should have the index of 2. The first clone has the second x and y numbers. The creating clone has the first x and y numbers. I'll create 2 clones. I might in the future want to create a lot more, so I'll use a loop. Control, repeat 2 times. I'll need new clone index to be increased after each one, so each clone gets a unique number. Data, change, new clone index by 1. Now I need to initialize the clones. Control, when I start as a clone, I want to set the clone's index to new clone index. Data, set my index to new clone index. I have a problem though. There's a race condition between the creating sprite and the new clone sprites. I need to be sure the clone gets the new clone index value before the creating sprite changes it by 1. I've gone into more detail on this in an earlier challenge. For this challenge, I'll say the problem is easily avoided having the creating sprite wait for the clone sprite to let it know it's safe to create the next sprite. I'll use a variable to coordinate between the 2 sprites, make a variable. I'll call it finished initializing, question mark, global, okay. Bring it down. I want to set finish initializing to an n before I create the sprite. Finished initializing, n for no. Then I need to wait until the clone has been created. Control, wait until. I need to wait until finish initializing is a y. Operators equal y data finish initializing. Now what will happen? New clone index is set to 2. Finished initializing is an n. The clone's created. This creating sprite is now waiting for finished initializing to be changed to a y. When it is, it'll advance to creating the next sprite. If the clone does not set finished initializing, the creating sprite will be stuck right here. Set finished initializing to a y. When the clone sets finished initializing to a y, the creating sprite can continue execution. I'll try it now. Stop. Green flag. Notice that new clone index is 4. It started at 2. 2 clones made would add 1 a couple times and leave it at 4. Also notice that finished initializing is a y for the last clone. Were the clones created? Where are they? They're with the creating sprite. No more sprites. Now I want to make the clones move. I want them to move when they're first created and each time the U key is pressed. U for update. I'll make a new procedure block. More blocks. Make a block. I'll call it update. Okay. I want to update when the clone is created. I'll add it in when I start as a clone. Here's the update procedure. I want it to move. I'll go to motion. Go to XY. I want the X and Y positions to be updated by the sprite's delta X and delta Y values. I'll go to operators, plus. I need the current X position, motion, scroll down, X position. Now I need the sprite's change in X position, its delta X value. Go to data, get item. What index should each clone use to get the delta X value? It should use my index. My index is 1 for the creating sprite, 2 for the first clone, and 3 for the second clone. Now an update is called, the X position will be changed by adding the delta X value for each sprite. For the creating sprite, my index is 1, 0 is added, no change. For the first clone, my index is 2, 3 is added. For the second clone, my index is 3, negative 3 is added. The first clone is going to move to the upper right, and the second clone is going to move to the lower left. I need to do the same thing for the Y position. Duplicate. Change delta X to delta Y. I'll right-click. I can't change X position, but I can delete it. Get Y position. Scroll down. Y position. Add it into the goto. I can show the updates now if I add the handler for when the U key is pressed. I'll go to Events. When key pressed. When the U key is pressed, have it call update. Duplicate and remove this. I'll run the program now. Make sure it's stopped. Clones are gone. I can remove the variables from the stage. Go to Data. Uncheck. Uncheck. Interesting. Showing but unchecked. How about hide the variable? Didn't work. Again. Nothing. What if I select the sprite? Now if I hide the variable, now it's gone. It can be a little challenging removing the monitors from the stage when sprites have clones. Be certain the sprite is selected when you try to remove the monitor. I'll leave the lists on the stage for now. Ready to run the program. Already stopped. Green flag. I'll press the U key several times to get updates. Can see the sprites moving. Can also see accesses on the lists. Watch the indexes light up. These monitors are showing accesses to items in the lists. All the clones are changing. That's because all the clones have a handler for when the U key is pressed. I can make the sprites change their size. I'll have the middle sprite get larger and the clones get smaller. Instead of making another list for the size changes, I'll use an if-else. Control. If-else. How can update tell whether it's updating the creating sprite in the center or the clone sprites moving away? They each have a unique myIndex value. When myIndex is greater than 1, it's a clone. Easy enough. Operators. Greater than 1. When myIndex is greater than 1, it's a clone. I'll go to Looks. Get Change Size. I want the clone sprites to get smaller as they go away from the center. Have them change by -2. Duplicate. I'll have the creating sprite in the center get a little bit larger. I'll make it 4. A little hard to see. I'll move these up a little bit. That's better. I'm changing sizes here, so it'll be good to make sure my size is 100% at the beginning. Change 90 to 100. Now I'm running out of room a little bit. I'll do that. I also want the clones to disappear when they hit the edge of the stage. I'll go to Control. If touching the edge of the stage, go to Sensing, Touching, Edge. If it's touching the edge of the stage, I'll delete the sprite. Go to Control, delete this clone. I can only delete the clones. I'll put it in the if part for clones after the size is changed. Can't see all of update now. Move this. Bring this up. Move that down. I'll try running it now. Stop. Green flag. Okay. Press the U key. The middle creating sprite's getting larger, and the clones are getting smaller. I'll keep pressing the up key. See that they disappear when they hit the edge of the stage. Smalls are going to get. And gone. I'll stop the program now. One last part to this challenge. What would happen if update is called from the when sprite is clicked handler? Go to Events. When this sprite clicked, I'll make a little room. If update is called from here, what will happen to all the sprites? Make sure it's stopped. Start. Press the U key some. What's going to happen to all the sprites when I click on one of the stars? Time's up. As you can see, only the sprite that's clicked on is updated. This one gets larger, and this one gets smaller. It only affects the sprite that's being clicked on. Makes sense since the other sprites are not clicked on. I'm finished with this challenge. I encourage you to play with the example and get comfortable with coordinating the creation of clones and to be comfortable with accessing lists. Try changing the program. Try adding more clones moving in different directions. Try adding new effects. Try changing the program to automatically move instead of using the U key. Try changing the program so the delta X and Y values are randomly selected in a range. But most of all, have fun with the program. This is a Pico challenge, and this is Pico. A Pico's 1/1,000,000th. That's 10 to the minus 12. 12 zeros. A Pico is a very small number, so this is a very short challenge. Hide variable hides the data variables monitor on the stage, and show variable shows it. I could use them to show a variable's value for a little while, like showing a secret message. I'll get a new scary backdrop. Nature. Woods. I'll double click. Woods is my backdrop now. I'll create a variable, scripts, data, make a variable, call it secret. Okay. I'll move secret to the top center. I can hide this monitor on the stage. I'll click on hide variable, and it's gone. I could set the variable to turn left, show the variable, and hide it. Go to control to show it for 3 seconds. Wait, change the 1 to a 3. Now I'll run it, and the secret appears for 3 seconds. That was easy. I'm finished with this Pico challenge. I encourage you to have some fun with the show and hide variable blocks. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.